Unit Testing by Jesse Hernandez. What is unit testing? Unit testing is a way to check that each part of your software works correctly on its own. There are many different types of testing components. It is a method done by software, web, game, or backend developers. This method helps to verify small portions of software to make sure that it runs smoothly and effectively. How do programmers usually write difficult-to-test code? Making things private. This often means that the program can only be accessed in the class they were defined in, also known as encapsulation. Encapsulation is a method that allows developers to only show the necessary information. This allows for the external code to be considered neat, as the internal code will not be intertwined with the external. In order to make things private in the program, you must declare instance variables of the class as private. You then add getters and setters to retrieve your inputted values. Non-determinism refers to a test that passes or fails and the outcome is unpredictable. Non-determinism results in lack of isolation, which affects the outcome if tests are not properly isolated from each other. Using final keyword of a class as private. When using the final keyword, you cannot override or reassign a class, method, or variable. Long methods contain a lot of code and perform a lot of operations that can go different routes. This can become a problem because there are so many different routes that the code can take, which makes it difficult to isolate and test individual parts. The reality on how a programmer should write difficult-to-test code. Good OO stands for Good Object Oriented. This is a type of design that means that the code the programmer has done is organized and properly isolated. This makes the code easier to test overall. Dependency injection. This technique is used in unit testing, specifically object dependencies, which is when other objects that are needed are provided so it does not have to create it on its own. This is meant to be used as a testing framework. Dependency injection becomes very useful with testing because the programmer or developer can create fake or mock dependencies that will behave like the realistic ones, which makes your code easier to test. You do not have to rely on the realistic ones because the mock ones will hold its place until necessary. The programmer or developer has control of the dependents. Test-driven development, mostly known as TDD, is a methodology that combines software development and testing. This can be recognized as red and green factors. TDD usually tests functionality. Programmers tend to write the code with a current function in their minds until it is able to pass as green. At first, it will be red and will fail because there are no set functions. Once it is restructured, it will be able to pass as green. TDD helps to ensure a good quality code and maintainability. The cycles of unit testing. Analyzing the code. This is typically the first stage within the cycle. Developers or programmers outline the requirements of the code and continue to create test cases for each of them. Once the code is written, the analyzation process begins, once you are done implementing and testing. Creating test cases. Each requirement of the code needs a test case to properly ensure that it will run smoothly towards the end. The purpose of testing is to execute a quick functioning code. Analyzing and debugging. Some codes will have to be rewritten in order for the test to work. This step ensures that the test cases are accurate and effective to test the functionality of your code. Benchmark testing, also known as the baseline, helps to ensure that the code is in the correct format. Execution. Programmers and developers test the code to observe the results. Comparing expected results with the actual results helps to ensure a better executed code. This helps with debugging and maintainability. Debugging. To ensure that the code is functioning correctly, it is important to catch these bugs early on. Retesting. This step ensures that the code's functionality has passed and can proceed forward. The cycle of unit testing helps to ensure that the programmer's or developer's code is functioning well and can effectively catch the problems at an early stage of testing. This makes the process easier, quicker, and effective. What are the real issues of unit testing? Mixing new with logic. This creates a situation in the code because the method or the class are both creating new objects, which leads to complex logic. Using the keyword new will tend to make the testing process difficult because if you have a method that has created a new object and then continue to add a calculation, the test will now have to look into the new object and the calculation. Dependency injection can be helpful in this case because it will allow to isolate the code properly. The new object will be considered the dependent. Looking for things. This can mean many things within the code. The code can be too fragile, which can eventually break. Too complex and difficult to understand. There can be many values or conditions, which in return will make it harder to test because you cannot test something that does not understand what it is being tested for. Maintainability will often change for some values that are added in the future, which can affect the code later on. What are the real issues of unit testing continued? Work in constructor. When adding dependencies in your constructor, it is important to understand that some do not need to be involved in your test. Maintenance within the constructor can be complex. If you change your constructor, you will often have to update it. Global state, also known as singletons. Testing isolation can become difficult because if the programmer decides to change one thing, it will affect the outcome of another because it is often shared. This will then turn into non-deterministic results. Static methods. Procedural programming. Static methods are hard to test because there are no seams. You need to isolate something in order to test it, and you need a seam in order to isolate something. Seams in object-oriented systems are considered polymorphism. Polymorphism allows different types of objects to be accessed through the same interface, providing flexibility and efficiency in code design and execution. Deep inheritance. Deep inheritance can cause issues for several reasons, most of them because of test isolation. If a test fails, it can be hard to determine whether the failure is due to the code being tested or because of the behavior in which the base classes it inherited from. Dependency. There are some tests that tend to become order dependent, which means that these tests rely on inherited behavior. So the order in which the test runs matters as it will slow down the testing process if something is changed. Too many conditionals, also referred as if statements. If statements often become complex because each brand often leads to different outcomes. If there are many if statements, the programmer will have to write separate tests for each statement. In return, it could become messy and make the code harder to understand. If the testing portion relies on an if statement, this can also affect the outcome. It will become difficult to isolate. so the behavior between the code being tested and the result from the if statement will become harder to maintain because now it will be considered fragile. Progression of unit testing. Let's assume you're testing a car. You construct the car's framework in order to test its functionality. But the problem is its execution. Because the program isn't set up properly, you begin to break it down into subsystems and test each subsystem with external dependencies replaced by simulators. To simplify it further, this is considered mocking. The first step in breaking down subsystems is identifying external dependencies. This could be network services, file system, databases, or basically anything your code interacts with. Creating simulators or mocks copy the behavior of the real dependencies in the program. This allows the testing portion to be isolated. When replacing real dependencies with simulators, using dependency injection can allow you to pass the dependencies to your code instead of letting the code create itself. Another example. Assume you have a function that retrieves data from a database. In order to test this function, you do not want to hit the database while testing your function. Instead, the programmer or developer can create a mock database with the data that is required for the test to run. The function will be tested and the programmer will not have to be concerned about the database. The testing will be faster and easier. By testing each subsystem with external dependencies replaced by simulators, will make tests more manageable. This can be called functional medium test. Stage 2. Functional tests. Test a subsystem of the app with simulators for external dependencies. This refers to the mocking method. The programmer creates a simulator or mock of the database that is being worked on, and the simulator behaves like the real database, but in all reality, it is being controlled by the tests inputted by the programmer. The programmer's test focuses more on the behavior of the subsystem, and it will not affect the real database. Functional tests can simulate conditions not possible in scenario tests. Functional test focuses on testing individual functions or features of a system. This is designed to verify that each function works properly. An example of functional testing on specifically performance testing can help test how a function reacts under heavier loads and different networks. Developers can run these before submitting. Developers start by identifying functional test cases for the application. They can use a RTM, also known as Requirement Traceability Matrix, to ensure complete test coverage. There are also many different functional testing tools and techniques that can help developers ensure that the application is functioning. Functional tests are considered to be faster and less flaky. Red versus green. Green is high confidence subsystem is okay. Lower app coverage. Test focuses on class interaction. This is the state of a passing test. A green test indicates that the code being tested is working as expected. The goal at this stage is to write code that continues to pass the test, then refactor the code to improve its structure and efficiency without changing its behavior. Red. Confident that things are bad. Easier to reproduce failures. Still needs debugger to figure out what went wrong. This is the state of a failing test. To put it in another way, the test is not passing. When a test is highlighted in red, it means that the code being tested is not functioning as expected. The goal at this point is to write code that will allow the test to pass. Stage 3, Unit Tests. Unit tests test individual classes in isolation. They can simulate all error conditions. Developers can run these after each file modification. They are considered to be very fast and no flakiness. Tests are developed by first creating test objects, then selecting input values for the test, running the test, and finally comparing and analyzing the expected results with the actual results. What makes a good unit test? A good way to remember how good tests should be is by using the acronym ATRIP. A equals automatic. This checks test results for pass or fail automatically. T equals thorough. This makes sure to test all paths and scenario. R equals repeatable. Tests should be able to produce the same results every time. Tests should not rely on uncontrollable params. Uncontrollable parameters can cause problems in unit testing because it can be difficult to write a test that covers all possible values of an uncontrollable parameter if the behavior of a function is dependent on it. I equals independent. The most important information from unit testing is to make sure that tests should only test one thing at a time. It should only be testing one feature or behavior. Tests shouldn't be relying on one another. Isolation is key. P equals professional. Using well-vectored methods and making sure that tests run fast should indicate that the test has successfully passed. Unit testing and other types of testing. Unit testing tests small pieces of code. System testing, testing bigger parts of code and ensures quality control. For example, the complete API, which is Application Programming Interface. API is considered to be a connector that allows different software systems to communicate and exchange data with one another. Integration testing. This tests different parts and how they work together. Acceptance testing. End users come in to see if they are capable of using the software as intended. Performance testing. This tests the speed. Regression testing. This tests all the automatic tests. Security penetration testing. This spots weaknesses in the security of the system. Load testing. This usually tests to see if the application can deal with large loads of code. End-to-end testing. This tests the application as a whole. Over here we have a graph. At the bottom, it states unit testing. This is testing code in isolated small pieces. On top of unit tests, we have integration tests. This program units are combined and tested as groups in multiple ways. End-to-end tests. The entire application is tested in a real-world scenario. Then going down the triangle, we have efficiency. Going up that triangle, we have comprehensiveness. So how do you write hard to test code? First, you isolate complex codes. Second, you pick a technique that better serves your code. There are plenty of techniques that programmers and developers must know of to help their situation. Third, understand that there are many different types of systems that will help run the application towards the end. Make sure you refactor a code to maintain it. And lastly, dependency injection. Takeaways. Unit tests are a preferred way of testing. Unit tests require separation of instantiation of object graph from business logic under test. Unit testing alone is not enough to assure stability and performance of a system. Unit testing is a method performed by programmers and developers that focuses on small units of code. Functions or methods are often looked at to fix any issues early on to ensure the quality of the software. Unit tests are meant to be quick and simple so that they are easy to read and understand. It is important for developers and programmers to follow certain methods to keep the system organized and ensure consistency.